we're going to go ahead and get started here, and this chapter is going to be talking about transformations, okay, of geometric figures. Okay. So let's introduce some terminology first, and then we'll go through the individual types of questions that you're going to be asked to calculate or perform. All right, so there are going to be a reference to vectors early on. It's not something that's going to be emphasized a lot. And vectors are written, in this case, from the initial point for this P to the terminal point Q, and they're written with a vector symbol on top, which is basically a segment with half an arrow. And it is going to be pointing to the right, just like the symbol for ray. It's only going to point to the right, no matter which direction the actual vector points. And so this is spoken as, or this symbol represents vector PQ, which is this vector right here. And notice that the vector, when drawn on your coordinate plane, indicates its direction and the component parts to it. Okay, again, just to illustrate here, the initial point is this point J. That's where you start. The terminal point is where the vector ends. So on this point, or on this same vector here, it's the point K. And the vector is made up of the horizontal component, and that is the horizontal measure from the initial to terminal side. Okay, so it's in terms of looking at it as a slope, it's the run. It's the horizontal run of that vector, and then the vertical component is going to be the initial to horizontal rise, or sorry, the initial to terminal rise. And so you'll be able to identify the components by using the same process that you did when you calculate slope by looking at a graph. Okay? And so when you look at this, the horizontal part is the x part, the vertical part is the y part. So it should be it shouldn't be a surprise that the vector form, which is going to be, it's going to have these angle brackets here. And you will write your horizontal component first. So in this case, 4 units to the right. To the right is a positive direction. To the left is a negative direction. So here it'll be a positive 4. And then the second component is the vertical component up to, when you look at that, again, from P to Q has a rise of 2. That's your y coordinate. Has the run of positive 4. That's the x component. And so really, if you're looking at how this is kind of built up, this first portion right here is the difference of the x's. And this portion right here is the difference of the y's. Again, terminal to initial. Right, so that's what you're going to be using when you are being asked to put it into its vector or component form. And so just really quickly take this problem right here and identify what would be the vector shown. Again, should be really straightforward. Start at your initial side, go to your point, go to your terminal point. And when you're writing this, you use the angle brackets here. You put your x component first, the horizontal component. We move 1, 2, 3, 4 units to the right. So that's a 4 here. And then our vertical component, we then go down 1, 2. And so that's the vertical component. And so that would be your vector for this. Right now, you just like with slopes, you may not find this by just counting it on a graph. You might have to just look at the points given for the initial point and the terminal point, and then determine what would the vector be from that. So I want you to try that on this second point, again, unrelated to the image. Okay, so just take that initial point is point A, okay, and you're translating to that A prime point. So again, if you're given the coordinates and not just looking at the graph, this is the format that you're going to use for the component form. And so if you're looking, what takes you from -6 to -1? You go positive or negative. Moving from -6 to -1, you move positive 5 units, right? 5 units to the right, or positive 5 units. And then to go from -4 to -6, how far do you move and in what direction? 2 units down, which is -2. Perfect. And so that would be the component form for this vector. All right. For the most part, again, not going to emphasize this a ton, but that is when the textbook refers to this, that's what it's asking you to use, that component form with angle brackets. Right, so let's look at this next slide where we talk specifically about what is the transformation that we're beginning with. So this rigid transformation that we're looking at to start with are just sliding a graph or shifting it horizontally and vertically. That's called translations, okay, or translating an image. And so a translation is described as this rigid shift of all the points in a figure along some vector. Okay, and so when you're looking at this, you're going to be moving from a pre-image to an image. The pre-image is the starting figure in the transformation. Okay, so this is the figure before you apply your transformation rules. So in this case, it's generally identified with the letters with none of the apostrophe or the symbol for prime next to it. So ABCD is the original. Up here, your original pre-image is ABC. Okay, and then the image is the ending result, what the new figure is after the transformations are applied. And so this would be A prime, B prime, C prime, D prime. So that's the ending figure. So this right here, would be your image. So pre-image is the original. Okay, and then the image is the one that's created, the copy of it. All right, so when you are looking to make these translations or shifts, it's going to be described either verbally or you'll see it in a sort of an equation form, okay, or you can just count it out from the graph of the figures. Okay, so if we look at this first one, I want you to try this on your own here. Again, see how intuitive this is for you before I talk through it. But if you're given that pre-image of L, H, and J, and then you apply this transformation, horizontal shift 7 units to the right and a vertical shift 2 units down, and can you identify what the new points would be? All right, so you can think of these shifts as occurring as vectors here. So if you look at this horizontal shift and this vertical shift. So a horizontal shift to the right, just as it would be on a number line, okay, is positive. So we're looking at a +7, a horizontal shift, and the vertical shift is 2 units down, which is a -2. So if you're thinking of it as a vector, you're looking at it in this form. Now you can also think of this as an ordered pair. Okay, so here, if you take your original x coordinate and your horizontal shift is adding 7, and your vertical shift, you take the y coordinate and you shift it down 2. You can also think of this in terms of this ordered pair. So you can either think of it as a vector, okay, or as the shift in the coordinates. Either way, this is what you're really applying when you write your answer. So if you take your original L's x coordinate and you add 7, you get your new y, or the new coordinate 8. If you take the original L's y coordinate -3, subtract 2, you get your new y coordinate -5. So we'll do that for each of the sets of coordinates. For h, we take 2 plus 7, which is 9. We take the y 3 minus 2, which is 1. And then finally for the j, we take 5 plus 7, which is 12. We take the y's, -9 minus 2 more, -11. So that would give you your new coordinates based on either the vector or the shift in the coordinates on the coordinate plane. All right, so try this last problem here with the same idea. If you're given what the translations are, how would you express the new coordinates? So even though interpreting these shifts directly is going to give you the right answer here, I also do want to take any opportunities that I can when you are given problems that are kind of set up like an SAT is to go through strategies that are helpful on those types of questions, which is eliminating answer choices that aren't correct. So again, it's not a bad idea to, as you're going through, also eliminate choices that are not correct. So here, when you're looking at the transformation, we are shifting 1 unit to the right. So for the vector in component form, you're looking at a horizontal shift of +1, 9 units down. So the vertical shift is down 9. So there's our the transformation as a vector. And so from the coordinate form, we start with our x and our y coordinate, and we just apply those vectors. So +1 for the horizontal component, -9, and again, what you wind up with here is your answer. Again, you don't really, in this case, it's not necessary to eliminate answer choices because it leads you directly to the right answer. Okay. All right, questions on the translation rules? Okay, so the very last thing, the last type of question that you're going to see here, beside the ones where it specifically tells you the shift or it gives you points and you come up with the shift from that, is the graphing of these. Okay? And so when you are looking to apply the transformations, you also need to be able to recognize them from graphs and to actually graph them. So I want you to try this first question here. What is the transformation rule that's applied to go from the pre-image, ABC, to the final image, A prime, B prime, C prime? So which of those would be the transformation rules from the blue graph to the red graph? So this would be one where when you're looking at the options that you can do some elimination, process of elimination here. And we haven't specifically talked about dilations yet. Dilations occur when the figure increases or decreases proportionally in size. But we can see from the images that these are the same size triangles. They happen to be oriented in the same direction as well. They just get shifted vertically and horizontally. So we know it's going to be a translation, so we can eliminate those two options. So the next thing is just to make sure that you know what is your pre-image, what is your final image, because we're starting with point A and we're ending at A prime. So when we look at this, we're going up 1, 2, 3, 4, 5 units. We're going over 1, 2, 3, 4 units to the left, and that tells us what the transformations are. So up 5, left 4 is the solution to this. When you look from the original graph to the ending graph. All right, the final step, or the final type of question that you're going to see has to do with actually drawing and sketching the graphs. Okay, and so once again, without me going through it first, I want you to see where would you sketch this new triangle after the transformation rules where you're translating at 5 units to the left and 1 unit up. Okay, so plot those 3 points. And then I'll talk more about how the graphing works on MyOpenMath. All right, so if we think about these transformations as vectors, okay, so we translate it 5 units to the left. So as a vector, to the left is negative. So there's our horizontal shift, and it's 1 unit up. So there's our vertical shift. So that's the vector that we're applying. If we apply this to a set of coordinates, we just apply that x minus 5, y plus 1. So this is what's going to be applied to each point to get your new points. So when you're plotting your graph on MyOpenMath, first you're going to click the the button to indicate polygon. And then you're going to plot each point. So if we take A, so if we look at what A prime would be, we're going to take our original x-coordinate 3, we're going to subtract 5, so that gives us -2. We're going to take our original y-coordinate 1 and add 1 to that. So we get -2, 2. We plot that point. Okay, move on to the next point, B. To find the coordinates of B prime, we're applying the shift of subtracting 5, so -3 minus 5 is -8. 4 plus 1 is 5, so the next point that we plot is going to be -8, 5. There's B prime. And then finally C prime, we take -2, subtract 5, so -7. We take the y, -5 plus 1 is -4. That's okay. And then we have our new coordinates here, so -7, -4 plots our C prime. Now, as you are doing these, when you plot your first point to the second point, it'll create this line for you. When you plot your third point, it'll create this line for you. Okay, and so you do need to close this off. So you finish this problem by clicking back on the original point that you plotted, and that's going to close the polygon, and it should fill it in or shade it in as well. And that's when you know that you've completed the problem. Then you can click submit, and your question is done at that point.